Hello.
Hello.
Jumping to 5-5.
Hello.
I ordered more markers, by the way.
Yay, markers.
And they didn't come yet, but I actually found a box that I took from school that has some new markers in it. So we'll get some darker contrast, more contrast, darker color.
Ooh, polynomial long division.
Yeah, I mean, you're really going to get into the thick of it now, into Algebra 2. I chose something with only, so many days left of instruction. I'm trying to choose things that I think students struggle with when they get to Algebra 2. So we're getting into like the middle meat of it. As you notice, it's near, probably near the middle of the book.
Oh, I remember Mr. Knaus doing this, like when I was kicked out of class and sent to Mr. Knaus's room. I remember him doing this.
Who kicked you out of class?
Mr. Lewis.
Why? Interrupting?
Because I didn't have my homework done, so I couldn't do Mr. Bradfield's thing. So I had to go do my outline in Mr. Knaus's room.
That doesn't sound like kicked out, though. Kicked out to me, from my experience, is when you're not cooperating and you're stopping class from moving forward.
Okay. Well, I'm not doing that, but
I would say that day you did not meet the prerequisite, requirement for class.
I have to ask.
Yes.
So, how long do you think? Because I'm assuming.
How long must we sing this song? Sorry, go ahead.
I'm assuming that most likely my next teacher, who's teaching algebra to trig, I'm assuming they're about the same rate as we're going right now. How long do you think it'll take to start from chapter 1? Because I'm assuming that's where they'll start.
It'll be a while. So this will,
Okay.
You'll get a bunch of Algebra 1 that you'll remember from Algebra 1.
Okay.
And then when you get to this, your teacher might feel, for most of your classmates, that it's new to them. But for you, it'll be your second go-around.
Right,
And
so I can continue to ace the class.
From a different perspective, too. So he'll teach it a different way than I'm teaching it.
Okay.
Okay? So it's very beneficial. The people that think, well, I don't really need this, I'm going to check out for the year. Well, I mean, you're not taking advantage of opportunities. People say,
I need it printed now.
That person needs it printed now. I love all the conversations I hear because people's mics aren't, closed for that. You guys should default to being muted, and then you should, consciously unmute to ask a question. I think David said the space bar.
Yeah, space bar is temporarily unmute.
That's what I do.
And then only when you intend to speak do people hear you. I caught somebody's parent helping them on the test in 6th grade because they left their mic open and I could hear their dad going through the test problems with them. So, tough times call for tough measures, right? Desperate measures. Anyway, it's 8:30. Doesn't matter. Bob Rossism. All right, so we're going to go into chapter 5, and we're going to be dealing with polynomials, and we're going to be exploring some things that are true, and we're going to go beyond the quadratic now. Yay, beyond the quadratic. Okay, so you can see down below in example 1, quartic, I think they call it, functions, all right, and tertiary, like to the 3rd degree, and further. And then we're going to learn what's true about them, and we're going to learn how to factor them, where you might not have been able to do that before using long division and then synthetic division. Okay? All right, enough about that. We have a lot to do. We're not going to finish everything before the school year's out, of course. So I kind of want to get plowing ahead here. Any questions before we get going? Are we going to have another test this year? If not, I assume that's why everybody's not here. Everybody's not here? How many participants?
There's
There's only
34
34.
participants.
Well, usually it starts to, people are 5 to 10 minutes late. I don't know how off that is normally. What are they normally right when we start?
Right when we start, usually there's about 50, and then like maybe 4 or 5 flow in, and
No,
at most we've ever had 64.
Right when we start, there's like 45.
Okay, so maybe there'll be fewer people in here. Text your friends, tell them this is good stuff to know for next year, and maybe I will throw in a flash quiz just for people, and maybe it'll be pretty easy because to reward people for coming. So get the message out to friends that I'm not promising that opportunity, but maybe I will do that. I don't know. Let's see what happens today. If I don't see what I'm looking for, I might just give, something that only the Zoom people will be able to access. Maybe it'll be only a live thing that I put up on the board here, right? And then you'll submit that, and I'll timestamp it. You'll have to submit it while I'm on Zoom, right away. So I don't know. Maybe I will do that to reward people that are still showing up. So go tell everybody, and let's see if we can boost attendance. All right. Anyway, maybe they didn't get the message that locker cleanout was off. Well, they should be checking their updates. All right. And they should be coming to class. All the people yesterday who were in class, I told everybody during the lesson, and we had, what did we have, over 60 yesterday? Or the day before during review. I don't know. Okay, let's get to it. All right, so apply the remainder and factor theorems. So let's take a look at this. This is math language. When you read a math textbook, it turns a lot of people away. They think, oh, what is all this stuff? And they don't delve into it. And then what you do is if you delve into it, you got to keep your mind fixed on it and try to understand what these things are. When you divide a polynomial, f of x, okay, why does it say f of x? Let's stop. I put the mouse right there. Stop right there. Why are they calling the polynomial f of x? The value of it, right? But they're saying that it's a function, and it depends on x, all right? So then when you see that in the other ones, d of x, r of x, and later on g of x, things like that, it's because all of these are dependent on x. What they're saying is that you're not taking one polynomial and then in terms of x and dividing it by a polynomial that's in terms of some other variable like y or r or it's a or b. You're keeping everything in terms of the same variable x. That is why they're doing that. They're fixing them all together, saying that they're all talking about the same unknown. So when you're trying to apply this to a real world situation, that unknown is what you're looking for, or it helps you find points of interest like we talked about. So you want to keep it everything, and you only want to have one independent variable. Where else did you learn that? Hello?
Algebra 1.
Where outside of math, where did you learn that you probably only want to have one independent variable?
Science.
Okay, is there a reason? Is it coincidence that that's the same thing?
No,
No.
because by changing the independent variable to having multiple, then you leave more variability.
You don't know what's causing the outcome.
Exactly.
Yeah, and or to what extent each one is. You could talk about joint variation, and proportionality is fine. Is if you have an equation that will link two variables together, then maybe with a system of equations you can do that, right? And that's why it's important to learn systems of equations. Okay, but right now we want one independent variable, and we want to see what it causes. And so, with the quadratic, it causes a parabola. With linear, it causes a line. With these functions, you're going to get all kinds of weird squiggly lines. What does it cause? And then how does it behave? And then how do we use it to solve problems? Okay, so anyway, that's why these are functions with respect to one variable x. It's the way for them to say, okay, you're only allowed one independent variable. Now, let's talk about that. When you divide it by some divisor, d of x, d for divisor, right? So you have a function f divided by some divisor, d. All right, how about 10 divided by 3? you get a quotient polynomial. You're going to get 3 1/3, right? Let's say that that's the quotient, Q. And a remainder polynomial. So the remainder. Let's talk about that on the board. This is all there. See, when you actually tear it apart and you look at it, what they're actually saying is you have some f of x, right? That's my f of x, divided by a divisor, d of x, such as 3. When you divide, you have a quotient, q of x, and a remainder, which is r of x. Okay? See that? 10 divided by 3 is 3, remainder 1. Any questions about that? That's what all those symbols are that they're talking about. Now, look at this. Is it true that when you have that quotient, see my mouse, and you have that remainder, what do we do with that remainder? We put it over the divisor, don't we? When I do 10 divided by 3, it goes in 3 times. There's the quotient, right? And when you have remainder 1, what do you do with the remainder? You put it over the divisor. So what they're saying is when you do a function divided by some divisor, you're going to get the quotient plus you're going to get the remainder over the divisor. That's what this is. Something simple that you all understand. They make it so complicated so that it looks like this weird thing. But that's all that they're saying. When you take a polynomial now divided by some other binomial is what we're going to be doing, you're going to get some quotient and you're going to have a remainder sometimes. Sometimes you won't. When will you not have a remainder? When would I not, then if you're not sure how to answer that, go back to my numerical example. When would you not have a remainder? Answer.
When they fit into each other perfectly.
Which means that the divisor is a what of the numerator?
Factor.
A factor. So if this down here is a factor of that, then the r of x will be 0. You will not have your remainder will be 0. Right? And you don't have to write 0 over what you divided by. You could write, let's say I divided by 2 instead, right? My remainder would be 0 out of 2. Okay, so r of x would go to 0. The quotient would just be a whole number 5. Okay, so that's what they're saying. So if the denominator is a factor of the numerator, then the remainder will be 0. If it's not, then you have to write the remainder over the divisor. That's it. And that is a very helpful way to start before we start dividing functions by other functions. Nice clean marker. I love it. Okay. I think the point was made there. Okay, so the degree of the remainder must be less than the degree of the divisor. See that? The degree of the remainder must be less than the degree of the divisor. So, take a look at this. If I do this, let's do x plus 3 times x minus 5. What does that give us? X squared minus 5x plus 3x minus 15. Okay? So that would be x squared minus 2x minus 15. Let's say that this is f of x. Okay? And let's say that my divisor, d of x, is going to be x plus 3. I'm going to divide this. I'm going to do f of x divided by d of x. Okay? So I'm going to do this. I'm going to do this divided by x plus 3. Well, once you factor this, you did this in Algebra 1, you get x plus 3, x minus 5, and then you have that. What happens to your x plus 3s?
You cancel.
They cancel out. What is left over, therefore, must have a degree. What's the degree of x minus 5? What degree polynomial is that?
1.
1.
It has a degree of 1. What they're saying is because you divided by something that's in terms of x, then the degree has to be, the degree of your quotient must go down. It cannot stay the same. You're going to lose dimensionality out of it. Okay, so the x squared, and that might start at x to the 8th. But when you divide by any other function in terms of x, your quotient has to have a degree that's less than what you started with. Okay?
But isn't that intuitive?
Yes, it is. But I want to make sure that that is on your mind. And when that's on your mind, that might it might occur to you to do something that you wouldn't have done. Okay, so one way to divide polynomials is called long division. All right, so I want everybody to try to do this one here. Divide f of x by x squared minus 3x plus 5. Go ahead and try to do that using long division. And when I say long division, I mean exactly what I'm saying, what you would have done when you did long division in elementary school. Same long division I'm referring to. Put it inside your little tool. I wonder for how many of you this type of math is a breath of fresh air compared to the geometry.
Quite a few. I just am stressed though.
It's different, and yet it's connected.
There are now 53 members in the room.
Good. So we're actually doing okay. I wonder if anybody came because I just said that. I advertised possible extra credit.
Possible extra credit?
No, possible extra quiz attached to rewarding people that are showing up. Okay, so you're doing this division here. Anybody stuck and do not know how to move forward?
Wait.
Yes.
Oh, okay.
Polynomial.
No, wait.
Specific method to it.
Okay, here we go. This is what you're gonna do. Everybody watch.
Oh, wait.
Hold on, don't shout anything out. You are going
Mr.
to,
Rosenthal, wasn't 3x, wasn't this the function, the original function that's not being divided? Well, the function that's going to be divided now, wasn't it 3x to the 4th?
yes. Thank you. And I have it right on my screen in front of me and I still wrote it down incorrectly. Yes, these should be in descending order, by the way. Okay. Now, watch what I'm going to do. I need to make an adjustment here. I want this to have every degree counting down from 4. X to the 4th, x to the 3rd. Where is my x squared? I don't have one, but I can.
0x to the 2nd.
So watch what I do. I'm going to take this off. And I'm going to actually, this is important, so please write this down as an important step. 0x squared, right? Now I can put in what was there before, plus 4x minus 6. X to the 2, x to the 1, x to the 0. All the way down to x to the 0. That's first. Questions about me adding that in there? Next. What I want you to do is completely ignore the minus 3x plus 5. Completely ignore the minus 3x plus 5. I want you to see how many times, what do you have to multiply to x squared to get 3x to the 4th? Well, I'm going to need a 3. I'm going to need x squared. Got it? When you are distributing, remember, the divisor times the quotient gives you the dividend, right? Right? 10 divided by 5 is 2, so 2 times 5 gives you 10. So if this is my quotient I'm getting up here, remember that when you multiply these, if these are the leading terms, remember FOIL, first term, Mr. Knaus doesn't want you to do that because there's all this type of stuff. But you are always going to do the first term times, you're going to do the first term times all of the terms, the second term times all the terms in the other one when you distribute. So that means in the very beginning, I must do, I have no choice, I at least have to do, to get my first leading term, I'm going to have to do first term times first term. So I know for sure x squared has to be multiplied times that to get a 3x to the fourth. But I also know that if 3x squared is the first term in the other group, that has to get multiplied times each of these. So that's what you start to do. So as I'm multiplying this back, I'm going to multiply it out. 3x squared times x squared is 3x to the fourth. 3x squared times...
Negative 3x.
No, 3x squared times x squared is 3x to the fourth.
Oh, yeah.
Okay? 3x squared times negative 3x is negative 9x cubed. Now you're going to see the purpose of having 0x squared there. Now you're going to see why we did that. 3x squared times 5 is positive, I think I need to retire blue, positive 15x squared. And I think blue is retired. Yay, thank you, blue, for your service.
Wah, wah, wah.
And red's almost out the door, so let's go back to red. Let's go to red.
Green looks like it was just born.
So I know there are other things here, but how do you use the distributive property when you have two groups being multiplied? Don't you do the first term times each of the terms? So these values are going to show up, right? All right, so what do you do when you have this? How many times does this go into that? You multiply, and then what do you do at this point? You subtract, don't you? Don't you subtract? Yes.
Yeah.
Yeah.
Yes. So I'll show you in a numerical example. So if I have 122 divided by 5, you do 5 goes into 12 twice. That's what I'm doing here. 2 times 5 is 10. And then what do? You subtract. These cancel out. This goes to 2. And what do you do then? You bring down the next digit. See that? Then what do? 5 goes into 22. 4, right? Isn't that what you do? So, yeah. So we're not going to do anything different. It looks weird, but it is the same thing. Okay. Subtract 3x to the fourth minus 3x to the fourth. Gone.
Wait, wouldn't we start with the rightmost?
No, you don't need to.
Okay.
Because
Wait,
they're like terms. You can only put together like terms. It doesn't matter the order.
where did you get the minus 9x from? And the plus
3x
15?
squared times negative 3x.
Okay.
Once you have this, you have to multiply. You have to distribute it to each
Then
one.
do we drop down the next term?
I'm not there yet. I have to subtract. So you might want to do this. If you're subtracting all of these, you might change the sign and add. Negative, positive, negative. And now just add them. Okay? So 9 minus 5 is 4x cubed. And this will be minus 15x squared. And yes, then you drop down the plus 4x. Okay? Now you start over. What did I do before? So there you have your process. Nothing is going to change. You've learned it all. Now it's just doing it again. So let's do it again. What did I do? Try to remember what I did. I tried to see.
You divided you divided 3x by x squared.
3x to the fourth, yes.
3x squared, yeah. So the first term divided by the first term in the divisor.
Yes, so it's how many times does x squared go into 4x cubed? 4x, positive. So plus 4x. Then what did I do? I have to, Daniel, distribute this to each of these so that I can get all the terms underneath. 4x times x squared is 4x cubed. This one will always match. Why will it always match? Because you figured out how many times it went in. It should go in exact every time, the first one. So the first one always gets canceled out. The other ones, they either do or they don't. 4x times negative 3x is negative 12x squared. 4x times 5 is 20x.
I'm sure.
And you will subtract. And when you subtract, you could just change the sign and add.
The black marker is so juicy.
I know, it's good, huh? So this is negative 3x squared This is negative 16x, and we will drop down to minus 6.
Mr. Aristotle, could you
Yes.
slow down?
Yes, I will stop and take questions. I've done 2 rounds now, 2 cycles. First cycle in blue, second cycle in black. Well, the first cycle in blue and red. I will do the next cycle in pink. Or
Do we drop down like 0 whatever to keep divided? I don't know.
no, you'll see what happens. Remember, your quotient
Is that the remainder?
your quotient is going to drop down in degree. So right now you have a degree 2, a degree 1. You're going to get your last term here, and if there's anything left over, it's
That's
a
a remainder.
remainder, and you can stop.
Oh, okay.
Okay. Anybody still need more time to process or to ask questions?
I do. Just need to write it down.
No problem. Take your time.
These are fun.
If you do, other people do as well. Oh yeah, this is just the step 1, and then we'll do synthetic division,
Ew.
where we get rid of all the variables and you just pay attention to the coefficient.
Wait, Mr. Rosenthal, do you continue when we get back to it? Do you need to figure out how much times x squared goes into minus 3x squared? Like, do you need to?
Oh yeah, we're gonna wait.
that?
Yes, we're going to do that. Yes,
Oh, okay.
and that's going to go here in the quotient. Søren, you just give me the go-ahead. Awkward silence.
I'll ask because one moment. All right, I think you can proceed, Mr. Aristotle.
Okay, so we've gone through 2 cycles. Your degree has gone from 2 to 1. Now your last one. Now that doesn't mean that there's not going to be a remainder. Maybe in the first example that this book, the author gives you, there might not be a remainder. They might want you to just see the process first when there's no remainder. If there's no remainder, then the next thing you're going to do, it's going to line up with everything, and you're going to get negative 3x squared minus 16x minus 6, right? The exact identical thing, if there's no remainder. Here we go.
There is a remainder, sadly.
Okay, that's fine. X squared goes into negative 3x squared. Negative 3 times. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is positive 9x. Yep, it's not the same. Negative 3 times 5 is negative 15. Okay. Okay, now underneath, you're going to subtract, which means you'll change the signs and add. I think that's a little easier, you'll make fewer mistakes. This cancels. You get negative 25x plus 9. That's your remainder. This is r of x right here. Okay, so how do I write my final answer? What is
I think you
what
would
is the
write it-
quotient?
It's over the original. It's over the original divisor.
It's over the original divisor. Exactly. This is the original divisor in green. So your solution looks like this. Your quotient, 3x squared plus 4x minus 3 plus, you're adding the remainder. Your remainder is negative 20, or you could do minus because this is negative. So watch, I could do minus 25x. Oh, no, you don't want to do that. You got to be careful. Okay, plus, because then you got to subtract the whole thing. Plus negative 25x plus 9 over my original divisor here. I'll put that in green just so you know where I got it. This is your answer. If there's no remainder, by the way, then this one here is going to be exactly identical so that when you subtract it, you get a 0 remainder. That's going to happen a lot. And it'll be pleasing to you, probably, aesthetically. ¿Hay preguntas? Questions?
Why didn't you continue down and divide the 25 and the 9?
Okay,
It can't be divided.
hold on.
Second degree polynomial and they're first degree.
I'm going to answer that question this way. 3 into 10, 3 times. Okay, 3 times 3 is 9. Why don't I try to see how many times 3 goes into 1?
'Cause it doesn't.
Why don't I drop down a point and do that? And put a point there. That's going into decimal form. Okay, so if I were to try to do that, then it would be the equivalent of going into decimal. But we're doing it as a fraction. So if you're going as a fraction, do you put a decimal and keep going?
No.
Well, you
yeah.
just take the remainder and you put it over the divisor, right? How did I know I reached the remainder? Well, when your degree goes all the way down to 0, then the next item that comes out is the remainder.
And generally, another way to tell is when the item you're supposed to be dividing has a degree lower than the divisor.
What your divisor and is a degree 2, and what you have now is degree 1. Okay, all right.
I hope we get quite a bit of practice with this.
Yeah, that's what the
More
homework.
practice problems, yay.
Yeah.
How is it already 9 o'clock?
It's a meaty subject. Students, it's such a good thing to get this practice now. When you do this with your teacher next year, you guys really should be able to, they might be surprised. They'll think that they had the best class ever. How are you guys so good at it? You'll actually make the teacher think, the teacher might even get the wrong idea that what they're doing is the perfect way of teaching it. And they might have, and then the next year may not happen that way and they'll be stumped and it will confuse them for their whole career. They might never know because they'll have a false pattern and they won't be able to justify. You'll have to tell you'll have to warn your teacher about that if you want to be nice.
I'd rather like not mentally torture me.
No, because that's going to torture them for the rest of their life. They'll be doing it possibly the wrong way for the rest of their carir.
Oh wait, I'm not
Or
even.
Mr. Rosenthal just tells them what he did.
Okay,
We have an exam.
try this one in example 2. Go.
Will we have an exam on this, Mr. Rosenthal?
We really have a limited amount of time. I'll be seeing you guys
that's-
Friday.
That's what I was thinking.
And then I'll be seeing you guys Monday, Tuesday, and Wednesday, and then I think that's it. Maybe in Wednesday I can have something in the place of like a final, have something worth some kind of credit.
No, thank you.
No, you're not going to have Mr. Knaus next year. You're going to have Mr. Nuno. Or
I
Nuno.
know.
Nice name for a new teacher.
Yeah, new teacher is Nuno. Okay, you guys are doing example 2 right now. Mr. Nuno was a teacher for 16 years, I believe, and he's coming from many years at Eagle Rock Highly Gifted Magnet. So he was teaching highly gifted high school. So he's coming to you now with calculus and computer science background. He's a computer science guy, and he's
cool.
He's like Mr. Knaus.
I won't be here next year, but that sounds cool.
He really enjoyed. You can tell he's passionate about teaching, and he likes learning. So when we interview teachers, we're not looking for somebody who knows the math. That's kind of like what we're teaching you guys. We're looking for somebody that loves to do the math and the science and just enjoys the process in general. And if we can just try to beat you guys over the head with that we don't care about the.
I don't want to be beaten over the head.
No, I know it's a metaphor, good thing, right? But we want you guys to really get the sense that we're not in it for the grades and that kind of thing. We're in it for the fun of learning, the fascination of it. Really, the people that go far in these things, they have a fascination with it. You really can't go too far in anything if you're not somehow fascinated with it. I don't want to say that that's an absolute. It's not a physical law of nature. It's more of a soft science, like a sociology thing. Anyway, do this problem, please. Doesn't matter. Beat the devil out of it.
Oh, Mr. Rosenthal, just a question. After you subtract the result from the first line, do you drop a term?
Yes. You sure
Okay.
do.
And do you divide all of the items in that term by at the same time? So, for instance, if it's 7x squared minus 7x, well, it's if you divide that by x, it produces 7x minus 7. But would you write that at the top?
I'm not sure if I'm following, but let's try the best you can, and then we'll go over the problem and you'll see.
Mr. Rose, what I mean is that if you have a term, if you subtract the result of the division, and you get the term 7x squared. So
at what phase do you get 7x squared? When? Oh, you mean up here in the quotient?
yeah, no. So you see, just an observation. If you divide x into into x cubed, you would get
X squared.
Yeah, x squared. Then if you multiply it back out, you get x cubed plus 2x minus 2x squared. Then you're changing the signs. You would get minus x cubed plus 2x squared.
Mm-hmm.
Then you get 7x squared. And then do you drop down to 7x?
You sure do. Minus 7.
And then do you divide the x by both terms at the same time?
No, you didn't do it here. You never do it. You always do leading to leading. Only leading to leading.
Understood.
Good.
In this you get a term 0 remainder.
All right, hold on. Let's see. This is going to be times 7x.
No, you don't.
I don't think you do, David. Don't get upset with him, though. Be patient with each other. Here, you guys can see me doing it if you want to see. Drop it down. I haven't done this in a long time. It's really not that bad. Plus 7. 7 times x is 7x. 7 times negative 2 is negative 14. Change the signs. And you get a remainder of 16. What I usually did, I remember in school, I would take that and I would just leave everything right here. Plus 16 over x minus 2. And then I would do this so that I didn't have to rewrite everything.
Yeah, I would just do that too if I were.
Yeah, I know you guys some of you guys like to do that. You don't want to do extra if you don't have to. That's fine. That's easy to read for me. I know when I'm looking at answers, I can just see I love when students box their answers. My eyes automatically go right into that box. It really targets it for me.
Hey,
What about circling
we
the
have to-
answers?
Yeah, not as good, but yes.
do we have to do
That's probably because a circle covers more area.
what did you do?
So yeah, I'm looking at more empty space. So it's less targeted. So I guess a triangle would be best.
Ooh, a triangle.
No, don't do that.
Oh, okay.
But it wouldn't fit in properly, so it wouldn't work.
Buried it.
If you do a pill shape,
Well, you can make it.
You have to come out far enough.
Slash undo.
you could do a pill shape, best of both worlds.
No, that's still going to cover more area than a rectangle.
Not as much as a circle.
No, actually, it would cover less area.
Are you sure?
Yeah, because you're rounding off the edges.
You
Lowers
are rounding it off. You're
lower
right. It
area.
must take less area. You're right. Let's do pill shapes next time.
Pill it.
You guys are so funny. Okay, questions
Why are
about...
we having an argument about what shape we would box our answers in?
No, pill your answers. Come on, David, get with it.
Oh yeah, pill our answers, right.
We're going to pill our...
So the remainder, do we have to put it over the divisor, or can we
We
just...
might have just coined a new phrase. Maybe
Yeah.
that's never been mentioned ever. We don't know. Okay, anyway, any questions about how to do this?
Press the toggle for a few. Ah!
You okay over there?
Scary!
All right, no questions. I'm going to move along.
Yeah.
David, mute yourself, please.
What in the world happened?
I don't know. Okay, you guys, try those.
Encounter the devil.
Hey, Mr. Rosenthal?
Are you okay, David?
What?
Are you okay?
Yeah. Oh, was I unmuted for that? Sorry. So for the remainder, do we have to put it over the divisor, or can we put all whatever the remainder is?
If you have 10 divided by 3, you're asking me, can you do what?
If I have 10 divided by
If you have
3,
10 divided by 3, and Mr. Rosenthal is saying it's 3, and there's the remainder over 3. You're asking me, do I have to put it over the divisor? What would your alternative be in this case?
R1, capital R1.
Oh, remainder 1. Got it. No, we're not doing remainder 1.
Okay.
Let's put it over the divisor.
Okay.
Just like when you went to middle school, your teachers didn't allow you to do remainder 1. By the way, when you do modular arithmetic, then the remainders are important. Okay, so we're doing those examples. I guess I'm going to start doing them too. And then we're going to learn synthetic division, a whole new thing, a way to do the same type of problem.
Okay, what's synthetic division?
You're going to see momentarily.
Okay.
I'm so excited for you. Okay, be careful in number 1. It doesn't have an x squared term. Make sure you put a 0x squared there. And later on, it could be missing other things.
Wait, I have a question. So you said 0x squared, right?
Yeah, look at my screen.
Why is it 0 and not like just 0? Why is it 0x squared and not 0?
Because I want to have a like term when I'm doing this. I'm going to get some amount of x squared, and I want to have it match up with x squared.
Okay.
It's a placeholder. There's no value there because of the 0 property of multiplication. All right, I'm going in on this first one. Because I want to leave it so other people can do the next one. We're going to kind of be doing this simultaneously so people can get what they need. If you're getting this, just go on to number 2. If you still need to look at what I'm doing, go to my screen and watch me do the first one. X squared times 2x squared is going to give me 2x to the 4th. So now I multiply back, 2x to the 4th. 2x squared times the middle term is 4x cubed, positive. 2x squared times -1 is -2x squared. So if you want to look, now what you do is you need to subtract. So I just change the signs, and then I add. Gone. This is -3x cubed, positive 2x squared. See, by having a 0x squared, I could add positive 2x squared to it. Okay. If I didn't put that, I would have an x right there, and I'd be confused. Wait, why is my 2x squared under an x? I can't put them together. So by me bumping over the x minus 1, I give myself a place value.
Wait, if you multiplied by a minus sign, shouldn't it be minus 2x?
I change the signs because I'm subtracting everything.
Oh,
Okay. Minus 3x gives me minus 3x cubed minus 6x squared plus 3x. Watch, Daniel, I'm going to change the sign. Plus, plus, minus.
8th graders, does any 8th grader remember in 6th grade when Miss Cacciatore made us do like 40 long division problems?
No.
I don't remember long division in
so.
pre-algebra.
I just remember not
I think
enjoying
we
this
have.
algebra.
I don't remember that is.
She yelled at
Not
Eli
that
for
fun.
eating an apple.
I wasn't in pre-algebra.
All right. Is that Jaron that I heard?
Yeah, Mr. Rosenthal.
Good to hear from you. Very good to hear from you. Okay. Okay, I changed the signs. You get -18x, and then this is +7. That's my remainder. Okay, so guess what I'm going to do? I'm going to be a little bit lazy. I don't recommend being lazy as a general rule, but I'm going to let you, instead of writing the whole thing again, you just put plus -18x plus 7 over my original divisor. There it is, done. And I kind of made it too high to pill. There, I just pilled my answer.
Excellent.
it doesn't stand out as much as a square because of the straight edges.
Wait a minute, Zig. Wait a minute. There are two perspectives, a glass half empty and a glass half full. You said that this is less area because you were thinking of this box. But wait a minute. What about the interior box? right? My interior box.
Seriously? Now you're arguing about boxes
My
again?
interior rectangle is smaller than your pill. Box your answers, everybody.
No.
What you make the pill smaller?
In its
Oh,
infancy.
Jeff, that's right.
My interior box
You can make
is
everything
smaller.
infinitely smaller.
Make an
until it's
interior
very
pill
simple.
inside that box.
I can't make a pill anymore because once I get there, oh, I guess I could start to round it there. That's an interesting.
My interior pill is
Make
smaller than your
a pill
box.
with a
Know
very
your
small
answers,
radius.
everybody.
Mr. Rosenthal, don't stop the movement so early in its infancy.
I know.
With rounded corners.
Yeah, you shouldn't.
So now we have a new debate.
Continue arguing.
Now we have a debate, and I love it. Okay, here we go. Number 2. I'm going to go to my screen now. It should be, go a little bit lower here, x cubed minus x squared plus 4x minus 10. I don't need to add any 0x's or 0x anything. X plus 2. Here we go. X times x squared is x cubed. X squared times 2 is 2x squared. When you then you see your speed at doing these starts to pick up. Okay, negative 3x squared. But don't, it's really easy to make errors on these problems. So don't go too fast on these. I strongly recommend. Okay, x times negative 3x, negative 3x squared minus 6.
Mr. Rosenthal, could you slow down a little bit because I can't really keep up.
Okay. Let me know when I can proceed. And I suggest you guys make these little arrows because sometimes you lose track of what you brought down. And then it takes you a while to go back and look, oh, so these little arrows say, oh, that was the last one I did. So now the next one I'm going to bring down is that one. Okay. All right. So this is gone. 10x, bring down the minus 10. Okay. X goes into 10x 10 times.
Mr. Rosenthal, as with the regular long division, will this just become irrelevant because now we're going to just use calculators to do this, or are we still going to do this? It's just a interesting question.
It's not really
Are
going.
we going to use calculators to do this?
It's not really going to become that irrelevant in my opinion because I mean. Algebraic calculations are still an important part of every field, and they're most often performed by humans. If humans don't have the necessary knowledge to perform algebraic calculations, then they'll be unable to function in those fields. It forms the basis for any educational system.
However, also look at this. This argument, you can argue it back to arithmetic. Why learn arithmetic when you can just add in a calculator? Please answer. And the answer to that question might be the answer to why do this. It might.
Sometimes you don't have a calculator.
Okay, there's always what if you don't have.
But you always have your phone.
Okay, so let's say.
Not necessarily.
Okay, let's say that usually if you're working with these types of things, you're going to have access to the calculator. There's still a problem. What's the why not just go back to the simple case of why learn arithmetic at all? Why learn any type of adding?
It takes more time to do the problem.
Okay, a time issue is the only problem you see? You don't see any other problems with having society learn arithmetic?
What's the basis
I think
for
the only
that?
positive to
It's
having
the
no
basis for
calculator in the
math.
problem.
No one can move on. No one can move on.
No one can
to
figure
higher-
out like
higher
more math
mathematics.
stuff without
No,
basic.
yeah, no one can move on to higher mathematics without knowing basic arithmetic first. They might become bad at it over time as they become entirely absorbed in higher mathematics, but doesn't necessarily mean they didn't learn it. They have to learn it.
Let me follow up with that. If I give you guys, since I've been giving you guys these distance learning tests, why hasn't everybody gotten a perfect score if you guys all have calculators?
We haven't been using
Most
calculators.
of us are.
It's human error.
Oh, so
No,
all of
because-
the mistakes you believe can be attributed to
Malfunction.
some sort of error made.
My
in
mistakes,
calculator.
Wait, you're saying that you don't expect any mistakes because of cheating?
No,
Oh,
I'm
Mr.
not saying
Rosenthal?
that. I'm
Mr.
trying to
Rosenthal,
get you guys to reason to a purpose of knowing how to do this versus just doing it in a calculator.
Mr. Rosenthal, Wait, what did you say again? Because I didn't catch that. Zoom
My
out.
question is, since distance learning started and everybody could use their calculators, why have I not gotten perfect scores for everybody? I'm going to answer it just so we can move forward. The answer is this. Having a calculator only is a tool. It doesn't mean you know what you're supposed to put into the calculator.
Human error.
When I'm showing you these problems, these are skills-based problems only. So you get the wrong idea that this is where the problem ends. You quickly forget that we use these problems and we apply them. So if you don't get your hands dirty with them yourself without a calculator, you really don't learn the ins and outs of how it works. And because you don't know how it works, you don't know how to apply it. See what I mean? You in a real problem, they're not going to give you what to do with your calculator. You have to make sense of the problem. And if you don't understand how these are all put together,
I guess so.
you will have an incomplete puzzle in your toolbox.
Yeah, Mr. Rose, like we learned long division, but now we don't really use it because we can just divide in our calculator. But then we wouldn't be able to know how to do this because this is a form of basic long division.
It is,
So,
and then of course
we'd have to learn long division anyways to do this.
And of course we're going to apply this. We're going to apply this. So you're going to have to see, how does this relate to real world problems? And then you'll see, well, I guess it was important to know how to do this. We're doing this. We're not going to even use this. We're going to use this idea to as a stepping stool to get to synthetic division. Synthetic division is going to allow us to find roots of non-quadratic polynomials that are, tertiary, quartic, to the fifth degree.
That's too bad. I like this method.
Okay.
Well, the next method is hold on, David. The next
Yeah.
method is directly related to it. It actually is this, but it's doing it with the coefficients. So you're going to see. But let's get to it. Okay.
Okay, let's just kill that and move on.
Yes, let's move on. You can get bogged down in philosophy too much, and then you don't get to the
You
content.
can, maybe you.
Okay, here it is. Look at that. Synthetic division. Okay, if you use synthetic substitution, we skipped that. I never learned synthetic substitution. So this might not make too much sense to you. Okay, but let's read it. In example 2, so we'll go up to example 2. If x is equal to 2, all right, what is going to happen is you're going to plug in a 2. 2 cubed is 8. 2 squared is 4 times 5 is 20. You get 28. Minus 7 times 2 is 14. 28 minus 14 is 14.
16.
Plus 2. You get 16. When you do f of 2. F of 2, when you plug a 2 in for x, you get 16. Just remember that. Okay. Now, when you do synthetic division, and we were dividing by, look here, x minus 2. In synthetic division, what are these numbers 1, 5, -7, 2?
Coefficients.
Those are, if we go back up here, 1, look at my mouse, 5, -7, 2. Those are the coefficients. If you had to add a 0x squared, then you need to put a 0, right? Okay. Now, this is what they're saying. X equals 2 here meets this expression that they put in here for synthetic division. X minus some k, right? The k in this case is 2. So when you put a 2, it's the same as doing f of 2 to get your remainder. F of 2 gives you the remainder. Okay? That is a key concept that you're going to see down here.
Where did they get the 2, 14, and 14?
Okay, so then we're going to get those through synthetic division, which is related to long division. Okay? I'm going to show you how to do it right now. Okay? So let's go back up to that same problem. Go ahead and rewrite down that same problem. X cubed plus 5x squared minus 7x plus 2.
Divided by x minus 2.
Okay, and yes, that's divided by x minus 2. which they're going to call it an x minus k. So here we're going to say k is 2 because x minus k. The x is the same, the minus is the same.
It's 2.
Okay, so what they're saying is to take the 2. So it's basically the opposite of that signal or symbol, the minus, positive 2. They're going to do this, 2. All right? And then what they're going to do is they're going to make this little box here. Okay? They're going to put the coefficients. 1. Show you my screen here now. 5. If you had to make a 0 at some point, you have to put the 0, but you didn't here. -7. 2. The remainder we know is going to be f of 2. If you plug a 2 in, the key concept is that the remainder will be 2. You don't have to do it that way. We're going to use synthetic division now. Here's what you're going to do. Step 1, drop your first coefficient down. Multiply 2 times 1. What is 2 times 1, everybody?
2.
2. Add. Okay?
7.
Why are we adding instead of subtracting?
Hey, Mr. Osta, how did you multiply it by 2 and then put it below the 5?
It's what's happening when you're multiplying here and you're putting it below. This would have been a minus 2 x squared would have gone below there.
Don't understand, Mr. Osta. So what did?
Okay, hold on. Let me share the screen. Hold on. Let me share the screen. When they did the original problem here, okay, look at this 5x squared. What's underneath? Minus 2x squared. And then they subtract it, so it changes the sign. So that you change it to positive and add it. But when we're doing synthetic division,
Because this is x minus k.
Okay, hold on. Yeah. So, wait. If I left this minus 2, then when I did the long division, this was minus 2x squared, right? And then I subtract it, so it becomes positive, and I added it. But look at what I already did here. By making that positive 2 instead of the minus 2 there, by saying I just want that to be k, the opposite of that, I've already changed the sign, and I can already add it to get the 7, is what I got.
I understand the background, but I don't understand. What could you repeat the step that you did before you put down 2? What did you do?
I dropped down the 1, and then I multiply 2 times 1. Okay? Maybe I should do the problem side by side up here. Let me give
And
it.
why, Mr. Osta, why is how does?
1 second. Let me do the problem simultaneously so you guys can watch it play out. So you do the opposite of the minus 2. You do positive 2. That accounts for all the, remember we were changing the signs here, okay? And then we're gonna have here the coefficients, 1, 5, -7, 2. Okay, now the first step is to drop this down, and that's a 1. Okay, so let's see, what does that look like here? The leading coefficient goes into the leading coefficient, x squared. Okay, so x squared times x is x cubed. Okay.
How do we know the degrees?
The what? You don't. You'll fill that in. So what you just wait for me to finish and you'll see. Okay, then what do we do? X squared times the minus 2 was minus 2x squared. And then what did we do? We changed the signs and added. There, the sign is already automatically changed. So you never have to do any sign changes. You're just automatically going to add. Now, watch what happens. We add these together. Okay, how did we get that 2? It had to be this here, right? The original 1. That's why it's 1. That's why whatever that is, you have to drop that down. So whatever that is, you're multiplying it times that to get the next one, okay? To get the 2. X squared times minus 2, and then you change the sign, okay? So here's my original 1, times the positive 2, already changed the sign. There's your 5 and 2. And you add them, right, to get that. Well, then where did it go here? you have this, right? 7x squared. These are canceled. Okay, so that's where we are, side by side. Okay. Now, for this to go into that, right? It's this 7x. Okay. Well, I already have 7. I know that that's going to be an x. I know that this is going to end up being a 1x squared. What I'm getting here are the coefficients of my quotient. You can see them coming out.
Multiply by the 2 and put it under the negative.
What's coming out here by doing this little algorithm are the coefficients. I'm getting all the coefficients of my quotient by doing this. Now what happens here? I drop this down, right? Okay.
David,
Then what am I going to do?
Multiply.
X goes into 7x squared. No. I already did that. That was 7x. 7x.
oh, Mr. Rosenthal. So the algorithm is you drop, multiply by that term, add
There's
the next
add.
term, and
But
repeat.
I know I could have just given you the algorithm. Follow this algorithm. But I want you to see where it's coming from. Okay.
No, I understand where it's.
Okay. 7x. Hold on. 7x times x is 7x squared. 7x times minus 2. You might understand where it's coming from, but this is for everybody. I want everybody to see. 7x times minus 2 is negative 14x. And then you change the sign. Because that was positive 2 instead of negative 2, the sign is already changed. I can then add right away. Cancel. What do I get here? I get positive 7x. Well, that would be the same as me. How did I get these? I did 7x times x, but then I did 7x times the negative 2. That means that I have to, if I got a 7, it has to also get multiplied to the 2. So 2 times 7 is 14. I'm doing the same thing. Drop, multiply by 2, put the answer there, add them. Multiply by the 2, add them. Now I'm going to stop doing this and I'm going to continue. This was, same thing here, 14 and negative 7, 7. It's giving me the coefficients of my answer. Okay? Then you drop the 2, right? X goes into the 7x 7 times. And guess what has to happen? The 7 has to get multiplied by that k again, or the opposite of k. 7 times negative 2 is negative 14. And then I have to do the opposite, and I get my remainder. Okay? What happens down here? 2 times 7, just like I had to do this negative 2 times 7. Here it is here. 2 times 7, 14. It's already the opposite. I can just go ahead and add. There's my remainder. Now I'm doing this type of problem, and it's now so much cleaner to do. Okay? I know from that first theorem that this one is going to be a degree less than what I started with. So if I started with x cubed, guess what this is? Watch me fill this in now. X squared plus 7x plus 7 plus my remainder has to be over my original divisor. Boom. Synthetic division. Voila. We will start with this on Friday. No school tomorrow. I'm going to be on campus. We are not meeting tomorrow. If you would like to stay for office hours to practice this more, feel free. If you have any questions, stay during office hours. Dismissed.
How do we know like what the powers are?
Because it's going to be 1 less than what you started with.
Oh, okay. Oh, because we're divided by 1x.
We are only going to be dividing here now with synthetic division. We're only doing it with degree 1. Binomials. Yeah. We're doing it with binomials.
Yeah.
Of degree 1. So when you're basically removing 1 degree every time. Your quotient will be start with 1 degree less.
Okay.
Oh,
There's the side by side. You can see how it all developed here versus how it developed here. This k has to be the opposite of the minus there.
oh yeah.
In a weird way, this makes sense.
Mr.
It gives you a new This is an algorithm, by the way. This is an algorithm.
Mr. Ostap,
this is a new algorithm. Yes, go ahead.
The process for synthetic division would be you drop the term, you multiply by that term, add it to the next, drop, multiply, add.
Yeah, that's it. It's so simple. It really simplifies the process. So here, I'll do the whole thing again. Actually, I could just make up something and it doesn't matter if it's nasty or not, because it doesn't matter if there's a remainder. We don't care if there's a remainder now. So let's make something up. Let's do x to the 5th plus 3x to the 4th minus 2x squared. I'm going to skip the cube term. Plus x minus 1 divided by x minus x plus 4.
Mr. Osthal, would this work for non-binomial divisors?
You would use long division for that.
Ah, so it isn't as useful as one would think.
Well, it's a quicker route for when you are trying to find roots. What do roots look like? They're in the binomial form, x.
It's not 30.
No, I already dismissed everybody. You didn't hear that?
Oh,
Look
no,
at
I
the
didn't.
participant numbers.
So, Mr. Osthal.
Okay, so let's do this. Your k is what?
4.
No, it's negative.
Sorry.
You need the opposite so that you can add. If you don't do the opposite, by the way, that's fine. Just every time you multiply, you have to subtract. Right? By changing the k to the opposite of that, you've already taken care of it. Okay? Now, coefficients are 1. What's the next coefficient? 3. There's no cube term, so 0. Then there's a squared term is negative 2. Then there's a x to the 1 is 1, and then negative 1. So those are all my coefficients. Drop your first one down. Negative 4 times 1 is negative 4. Add. Negative 4 times negative 1 is 4. Add. See how fast this is? So much faster. Negative 4 times 4 is negative 16. Add. Negative 4 times negative 18 is 72.
It is fast, Mr. Rosenthal, but only for a specific type of problem. And if you practice long division enough, eventually you'll be able to do it just as fast. And given the fact that...
I don't know if that's accurate.
Given the fact
maybe
that...
so.
Maybe so.
Maybe so, but as we go along, you make the determination as we go along. So now what does this mean? Well, we started with an x to the 5th. So this means we have 1x to the 4th minus x cubed plus 4x squared minus 18x plus 73 plus negative 293 over x plus 4.
But if you took the total efficiency of either method, Mr. Rosenthal, wouldn't long division come out on top because you can do multiple types of problems with it?
Let's explore that together. You know, I haven't been doing this for a long time. It's been a long time since I've done this. So I discover those kinds of answers as I go through again. Why is this important? Why is this method so useful? So maybe that's our mission together in these next few days of instruction. The answer to the question we're asking is why synthetic division? Let's go ahead and embark on trying to answer that question together, okay?
Understood.
Okay.
Thank you, Mr. Osthal. Have a good day. See you tomorrow.
You as well. Oh, not tomorrow.
Thank you, Mr.
Tomorrow,
Osthal.
Friday.
Next lesson.
You
All
can.
right, thank you, Mr. Rosenthal. Have a good day. See you on Friday.
Bye.
Bye.
Good. Oh, great. Okay. Bye, Mr. Rosenthal.
Bye, David.
Mr. Rosenthal,
Mm-hmm.
I have a question from the test.
Uh-huh.
So on the second page for the graphing question, I'm kind of confused on it.
The second page of the test.
Yeah.
I think that was at 0.3. And then I think it crossed at 3.0. That?
Yeah.
And it wanted to know the initial velocity of the ball, right?
Mm-hmm.
H of t. It depends on t, the time after the ball has been put into motion. Okay. Initial acceleration, or the acceleration is this, plus some initial velocity, and it started up at a height of 3. You understand the starting?
I think so.
That's not good enough. I need to know if you understand what I wrote here.
Not really.
Okay, so for these projectile problems on Earth in feet per second squared, it will always be, your leading term will always be negative 16 t squared on Earth, always. And that has to do with the acceleration due to gravity being 32 feet per second squared in the down direction. Okay, and then the calculus kind of explains why it's negative 16 and not 32, is when you take the derivative, you're going to get your negative 32. Okay? Now, we know that if I just drop something, it has no initial velocity. Gravity will start to make something accelerate at that rate. Okay? But I can throw the ball up or I can throw it down. Okay? And I can start with some initial, it's going to take longer for the ball to fall to the ground if I throw it up in the air, right? Versus just dropping it. Yes?
Yeah.
Yeah, and if I throw it down, it'll even go faster than if I just dropped it. So if that would be, if my initial velocity was negative, that's going to help out this negative, isn't it?
Yeah.
Yeah. And if I started at an initial height and height of 0 is the ground, I'm going to get to 0 super fast if I help it by throwing the ball in a downward position. I can prolong it and extend the time the ball is in the air if I actually toss it up. That's going to give me more time before the ball hits 0. The height is 0. So this is the function you need to write first. Okay, next, I can see when the ball hits 0. Here, the height is, this is height, h of t. Here's t, okay? At 3 seconds, the ball is at a height of 0 because of that point there. That's what this tells me. This told me where it started here. Height of 3 at time 0. Plug in t0. What do you get?
If
3.
t is, yeah, 3.
You get 3. So that's what this is showing me. Okay? All right. Now, I have enough information. I can say that my height is 0. See, I'm plugging it in for height. When the time is 3 seconds, I can plug in 3 seconds. Plugging it in for this t as well. Now I only have one variable. I should be able to use pre-algebra to solve. 9 exponents first. 9 times this is, let's see, negative 144 plus 3 v naught plus 3. Well, I can put these together right there, and I can get negative 141 plus 3 v naught. Okay, then I can add 141. Then I can divide by 3. And now I have my initial velocity. 3 goes into 14 4 times, 47. My initial velocity was 47. And that would be feet per second. I must have thrown the ball vertically up at 47 feet per second. And then gravity started to take effect, and it was accelerating in the down direction. So my ball slowed, reached a maximum point, and then started heading down faster, and at the 3 second mark, it hit the ground.
All right, yeah. So is this an extra?
No.
Is this extra?
No. Okay.
All right.
All right. Other questions, anybody? Nobody? Boaz, Russell, Luca, questions? All right, I'm going to end session. I'll see you guys Friday. No meeting tomorrow. Bye.